Hello class and welcome to today's lesson. My name is Mr. Holbert and I'm your teacher for today. So today we're going to be talking about angle relations. We're going to be introducing three of the more introductory ones, and then in a later video I'll have posted to this one. I'll go into some different applications of it and some different problems as well as some other angle relations. So angle relations are really important in geometry as we can use them to define shapes, we can use them to solve things, and arguably most importantly, we can use them to prove things as well. Because these are relations that hold true for angles no matter what. So we can apply these when trying to prove something else. We're going to start with supplementary over here first. So if you look over here, we got supplementary angle. Now, what a supplementary angle is it's an angle or angles that add up to 180 degrees, okay? So, once again, it could be angles, so I could have something like this, where let's say that this is 60 degrees and this is 120, and both these angles together would be supplementary. But supplementary angle is an angle that is 180 degrees, exactly. Like, I should really emphasize that point that these angles need to be exact. It's not like, oh, it's close to 180, it is 180. One thing to mention about supplementary angles is notice that it is a flat line. That is important. That's actually really important because it's a great way to identify if an angle is supplementary or not. Well, is it a straight line? If it is, guess what? It's supplementary. All right, let's continue. 2 is complementary. Complementary angles are right angles. So when doing, I'm going to write the complementary angle over here, just a bit larger for you guys. When doing complementary angles or when working with them, you have to know that they're 90, whether that's from the box or if, let's say, the problem includes a measurement, like it's like, hey, this angle is 90 degrees, then that's how you know that it's complementary. Complementary angle excuse me, always equals 90, and it's kind of the same idea as supplementary where you could possibly have a line in between and then these two separate angles add up to 90. So let's say that this one's 60 degrees and this one's 30. And then these two angles together would be complementary. So for complementary, I'd say just watch out, make sure that there's a way to determine that it is in fact 90 degrees. Supplementary kind of has that flat line idea. Complementary is just like, hey, look for notation. Look for something that says it is 90. All right, let's talk about vertical angles. A little bit different than the other two. So vertical angles, the relationship here is that, let's say that I have two lines crossing. So I have this line and this line. Vertical angles, what they are is like this angle right here and this angle. And vertical angles are always equal. They're always congruent to one another. So let's say that this bottom angle is 30 degrees. Well, guess what this opposite side has to be? It also has to be 30 degrees. No ifs, ands, or buts. That's how vertical angles work. You'd be shocked by how often just two lines crossing comes up in geometry and just math in general. And so it's nice to know, like, hey, where they cross, the opposite angles are, in fact, equal to one another. They're congruent. And it's excellent. So, a couple of things before we get started. I'm going to do some example problems of where we could use these or what type of questions you can be asked and how to solve these. I'll go through each one. But let's talk about some notation first. So I really just need to emphasize right now that angles, always, angles, when you're writing about them, need 3 letters. Now you're like, what the heck are you talking about, Mr. Holbert? Well, this is what I mean. Let's look at our vertical angles here. So this little intersection right here, let's call that A. And then we'll put a point here, that's B. We'll put a point here, that's C, so on and so forth, D, and E. So I need to know what angle you're talking about. And you need to be specific, right? This is mathematics. It's all about being specific. So I can't just be like, oh, angle A. Well, which angle? Are you talking about this angle A, this angle A, this angle A, or this angle A? Which one, right? I don't know. And so how we notate it is we use 3 letters. And when you say those 3 letters in a row, it should rebuild the angle. So let's talk about this top 30 degrees. If I wanted to mention that angle in my work, I would draw a little angle sign first off, little angle sign, then I'd rebuild that angle. So I'm going to start with C, then I go down to A, so A down, so C down to A, and then back up to B. Angle CAB, and it's that one right there. There's no questions, there's no way to get confused. It's this angle always. And notice that our middle letter is kind of the corner of our angle itself. And that'll always be the case. The middle letter for when you're writing it always needs to be that center part of your angle. And once again, my best suggestion for it is you are rebuilding that angle. All right, let's go ahead and get started, and we're going to look over some example problems of where these might come into play. To start off, how you are always going to approach these problems is you need to ask yourself this question. Am I setting it equal to 180? Am I setting it equal to 90 degrees? Or am I setting them equal to each other? You have those 3 questions right there, and you need to decide on one of them. Which one is it? This is, I kind of give it away here, right? I'm saying it's supplementary, so we know that we're going to set it equal to 180. So if we look at this first one, for example, it could be as simple as this problem where it's like, hey, this side is 180 degrees. Well, what's this angle here? Well, since my line is a flat line, it's straight, it's horizontal, perfectly horizontal, I know that it adds up to 180 degrees. So that means that I have 180 is equal to 110 degrees plus whatever the question mark is, right? And then from here, you would just solve for your missing angle, minus the 110 over, minus the 110 over. The question mark is equal to 70 degrees. So that is equal to 70 degrees. That is my missing angle. These ones are pretty straightforward, right? It's like, hey, what's the difference is the question. Now, let's talk about the second one, though, the second problem. This is where it gets a bit spicier. Here, once again, it's supplementary because I have 2 separate angles, but they're made up of they're 2 parts of a horizontal line, a straight line. But now I have a variable in them, and not only that, but I have a variable on both sides. So the question is, well, how do I solve it? And once again, you got to ask yourself the question, am I setting it equal to 180, am I setting it equal to 90, or am I setting it equal to each other? And the answer here is I'm setting it equal to 180 because it's still a supplementary relationship. So I'm going to do x plus 18 plus x minus 4, and that's all equal to 180. All right, let's combine like terms. So combine these two, I get 2x plus 14, because I can combine these two to positive 14, is equal to 180. And then, sorry, I'm not leaving myself a lot of room. We're going to subtract 14 over. 2x is equal to, what is that, 166. Divide both sides by 2. X is equal to 166 divided by 2, that's 83. And there's my answer. So if I come over here, x is equal to 83. Now, with these type of problems right here, as I talk about this, I'm just going to check my math real quick. When it comes to problems like this over here, be careful with what they're asking for. So if your teacher is just asking for the x variable, then you're done here. Bam, x is equal to 83. But let's say that your teacher is like, actually, I want to know this angle right there. You need to be prepared to take this x value and plug it in. So I'd have to plug it in, and I had to be 83 minus 4, and I'd find that this angle right here is actually equal to 79 degrees. 79 degrees, and then there's my answer. So just be careful. Please just read the questions that your teacher gives you. All right, question 3. Over here. These tend to be the ones that students struggle with because you guys can't see the fact that these 2 angles make a straight line. They do. It's a supplementary relationship. While it's a little bit turned and there's a lot going on here, at the end of the day, this is a straight line, and it's cut in, that angle is cut in half by two separate ones. So I'm going to ask myself the question, set it equal to 180, set it equal to 90, or set them equal to each other? And the answer is set it equal to 180. So I got 3x plus negative 2x minus 4 is equal to 180. Now I solve. Let's combine like terms. These become just x minus 4 is equal to 180. We're going to add our 4 over, x is equal to 184. This angle is actually not possible because it's negative, but so I accidentally goofed and made an impossible problem. Impossible because angles can't be negatives. But that's a good chance for me to talk about something else. Angles can't be negative, right? It's not possible. Like, angles can't be negative. You shouldn't have them be negative, at least, because then you're kind of going different directions. It's messy, okay? So let's stay positive, right? And so I'll have students solve these, and they'll get like x is equal to, here, let's give a better example. Let's say that we get like x is equal to negative 4. And then they'll recall, they're like, okay, my angles can't be negative, so then this is wrong. I did the wrong problem, or I solved it wrong. And actually, that's not true. That's not true at all. The reason why that's not true is that you solved for the variable, not the angle. So your variable can be negative. That is possible. But your angle itself cannot be, which if I took this and I plugged it in, that's what would happen. So I apologize for that little mistake. With that being said, let's move on to our next angle relation. All right, class, so let's talk about the complementary angle relationship next. This time I'm only going to do 2 problems because complementary tends not to come up as much, and when it does, it's usually in relation to triangles. So I'll kind of talk about that a little bit, but let's go ahead and start with our problem over here. So once again, when we're approaching these problems, we need to ask ourselves, are we setting it equal to one another? Are we setting it equal to 180, or are we setting it equal to 90? Here we're setting it equal to 90. Because I got my little box here, so I know that this angle is 90, so I get 2x plus 3 plus x plus 3. I'm setting all of that equal to 90, and then I'm solving. 2x plus x is 3x. 3 plus 3 is 6, which is equal, set that equal to 90. Subtract the 6 over. 3x is equal to 84. Divide this by 3, divide this by 3. And I actually don't have that off the top of my head, so let's go over here and check real quick. Bam, 28. Okay, so x is equal to 28. And bam, we were able to solve that variable using our angle relation, knowing that since it's a complementary relation, we set it equal to 90. All right, let's talk about 2. So more often than not, you kind of see these complementary relationships in these triangle problems, because what we do is we kind of make these complex triangles, and then we can use angle relations like our complementary one to prove things about them. And I'm going to go over some of that in a later angle video because it gets a bit advanced. But here's a basic idea here. I got this triangle here, and it's a right triangle, but we cut it down somewhere along the 90-degree angle. And I need to know what this angle is here. I want to know what that is. So since I want to know what that angle is, what I should do is I need to ask myself the question, am I setting the problems equal to each other? Am I adding them and setting it equal to 90? Adding them and setting it equal to 180? Well, it's a box, so I know it's 90, so I'm going to add them together. So 2x plus 36 is equal to 90. So let's subtract 36 over, subtract 36. 2x is equal to 54. Divide that by 2, divide that by 2. X is equal to 27. Bam. All right, I'm done. Or am I, right? Because, guess what? Excuse me. I asked for the angle measurement of that one. I kind of mentioned it earlier. I didn't write it down. I should have. Apologize. But I was asking for the measurement of the angle. So you have to take this x and you have to plug it in. So it should have been 2 times 27, and that would have given me 54 degrees. So 54 degrees is my answer right there. So once again, I just did this problem really quick as a reminder to ask yourself the question of, what am I asking for, right? What is the teacher asking for? Are they asking me just to solve for a variable, or are they asking me to solve for an angle? Make sure that you know the difference. One, you just solve for the variable, call it a day. The other one, you solve for the variable, like that's still step one, but then you have to plug it back in and solve. So with that being said, let's clear this off and let's move on to the last one. Alrighty, let's talk about these last problems. The last problems are going to be focused on the vertical angles relationship. And so let's look at our first problem over here. So once again, we're going to ask ourselves the questions. Is it supplementary? Are we going to set it equal to 180? Well, we have straight lines, but they're not on the same side, so no. Complementary. I don't see any markings or anything that could identify a 90-degree angle for me, so no. And then last but not least, am I setting them equal to one another? And since it's a vertical angle relation, the answer is yes, I'm setting them equal to one another. So I'm going to set these two equal. 2x minus 4 is equal to 30. And then I'm going to solve. So let's add 4 over, add 4. 2x is equal to 34. Divide both sides by 2. X is equal to 17. And that's my first problem right there. So set them equal to one another, just solve normally, okay? Nothing crazy. Don't get fancy with it. You get fancy with it, you're going to have problems. Let's work on problem 2. Once again, never skip it. Ask yourself the question. Is it supplementary? Am I setting equal to 180? No. Is there any indicators that there's a 90-degree angle relationship here to where it could be complementary? No. Are they on opposite sides of an intersection? Yes, they are. They're on opposite sides, so it's a vertical angle relation, so I set them equal to each other. So I got 30 is equal to x plus 1. Subtract 1 over, subtract 1 over. I get x is equal to 29, and I call it there. Bam. Already done. All right, let's move on to our last one. So once again, to start off, we ask ourselves the question, do I see any indicators that there's a 90-degree angle relationship here? No 90 degrees, so it's not complementary. Am I going to set them equal to each other? I'm not. I tricked you. It's not having a vertical angle. See? They're actually supplementary, because here I have my straight line, and if you look, this cuts that straight line somewhere, cuts it right there, making two different angles. So it is a supplementary angle relationship. So I need to add them together, 20x plus 30. Add them together, set it equal to 180. Subtract my 30 over, subtract my 30 over. 20x is equal to 150. Divide by 20, divide by 20. X is equal to 150 divided by 20. We can simplify that to x is equal to 15 over 2. And we can simplify that further to 7.5. Well, not simplify it further, excuse me. Reword it. So convert it to a decimal. So class, where students tend to make mistakes with these is they tend to mix them up, right? They aren't sure what the relationship is, so they never even get started. They're not sure if there is a supplementary angle relationship there because they kind of struggle to see the straight line. If you need to, you should just take a piece of paper and just like hold it up and try to block out part of it if you can. Try and isolate that angle, those angles to see. And the last issue is that students will forget that you got to set them equal to each other for vertical angles. That's the relationship for vertical angles, is they're equal to one another. So keep that in mind, please. Keep that little thing in mind. So just be careful with it. All right. With that being said, I think that's it for the lesson today. Thank you guys for coming to class and for watching. If you need some more math help, please consider subscribing. I have some other videos linked to this one that I'd suggest checking out, especially my other angle relation videos. Please watch those ones. You use angle relations a ton in geometry, and they're just fantastic anyways. They're very flexible. With that being said, thank you guys for coming to class today. My name is Mr. Holbert, and I hope to see you guys in the next lesson. Thank you. And here's a little bonus thing for those of you who watched to the end for some reason. I apologize that this video is a bit crazy. One of my problems was impossible, which that was kind of funny. and things were just a bit crazy. I had the wonderful privilege of welcoming my second kiddo into the world just yesterday, actually. So I'm a little bit sleep deprived, and I wanted to get this video out. So hopefully in the future, my videos will be a bit more structured like they normally are, but I wanted to get this one out to help my students. All right, well, thank you guys for watching until the end, and once again, hope to see you guys in a later lesson. Thank you.